Your crawler isn't failing, it's degrading. Requests are going through, dashboards look green, but the quality of your data is quietly getting worse. And that's the most dangerous kind of failure, the one you don't see while it's happening. Because crawling pipelines rarely break all at once. They lose accuracy gradually, request by request, response by response, until decisions, models, and analytics start drifting off course. You're on the Proxy-Seller channel. I'm Mark, and today we're breaking down how to debug your crawling pipeline like an SRE. We'll look at why most failures stay invisible, why monitoring isn't enough, and how observable proxies change the way production data systems are built and debugged. To understand why these problems keep repeating, we need to zoom out and look at the system, not individual tools or teams. In most companies, the data pipeline follows a similar path: crawling, ingestion, storage, then analytics. On paper, it looks clean and well-structured. But here's the issue. Research in Frontiers in Big Data shows that data quality problems are most often detected after ingestion, when data has already been stored, transformed, or used downstream. By that point, the cost has already been paid. What happens upstream during crawling and collection is largely invisible. Most monitoring and data quality tools are built to observe datasets and pipelines after they exist. They can tell you whether data arrived, whether schemas match, whether volumes changed, but they rarely show how data was collected or what happened at the request level. As a result, observability starts too late. Once ingestion is complete, individual requests disappear from view. Retries, partial responses, HTML instead of structured data, or subtle changes in source behavior are no longer visible to the system. That's why these failures seem so hard to explain, not because teams are careless, but because the architecture itself is blind upstream. When request-level events fall outside the observability boundary, failures don't look like failures. They look like normal data flowing through the pipeline, just with less value. And that's the core problem. We measure what happens after data arrives, while value is often lost before it even gets there. To understand why monitoring alone isn't enough, it helps to look at how SRE teams define system health. Google's SRE framework is built around 4 golden signals: latency, traffic, errors, and saturation. These 4 metrics are designed to answer one core question: is the service up and responsive enough to stay online? But even within this model, SREs warn that averages are misleading. Real system behavior often shows up in the 95th or 99th percentile, not in the mean. A service can look healthy for 95% of requests and still fail users, pipelines, or downstream systems through a small but critical tail of bad responses. This is where crawling pipelines break the monitoring model. A crawler can return HTTP 200, stay within latency thresholds, and process millions of requests while still delivering incomplete, delayed, or unusable data. Availability does not guarantee correctness, and a success code only confirms delivery, not analytical value. From an SRE perspective, this matters because crawling pipelines behave like distributed production systems, not batch jobs. Each request interacts with external services, retry logic, rate limits, and dynamic content. Small failure rates at the request level can compound downstream without ever triggering a traditional alert. Monitoring tells you that the system is running. Observability tells you why the system behaves the way it does, especially at the edges. And without that, debugging becomes guesswork. When crawling pipelines fail, they rarely fail loudly. Most of the time, the request succeeds, but the data doesn't. These issues usually appear at the request level, often in the tail of the system, the 95th or 99th percentile, far outside what average metrics capture. Here's what breaks most often. First, HTML instead of structured data. The requests return HTTP 200, latency looks fine, but instead of JSON, you get a rendered page, a login screen, or a CAPTCHA. Technically successful, analytically useless. Second, partial responses. Some fields are missing or stripped. The pipeline keeps running, but completeness slowly degrades. Third, delayed responses. Data arrives too late to matter. In data quality frameworks, timeliness is a core dimension, and late data is often as damaging as missing data. And finally, retries. Retries increase volume and hide unstable sources, pushing failures deeper into the tail instead of fixing the root cause. None of these issues stop the pipeline, none of them trigger alerts, but together they degrade data quality across its 4 core dimensions. accuracy, completeness, timeliness, and validity, and quietly accumulate cost. That's the key insight. A request can succeed technically and still fail analytically. The pipeline runs, dashboards stay green, but the value of the data keeps eroding. So why don't teams see these failures, even with modern tooling? The reason is coverage gaps. In most data stacks, observability starts downstream after ingestion. Tables, pipelines, transformations, and gold datasets are well monitored. Volumes, updates, schemas match, SLAs look healthy, but everything upstream, especially external requests, usually sit outside the observability boundary. Raw HTTP requests, retries, partial responses, and source behavior aren't treated as first-class signals. Once data is ingested, that request-level context disappears. As a result, dashboards stay green, pipelines run, data flows. But the system has no visibility into how much value was lost before the data arrived. And that's the consequence of coverage gaps. Root cause analysis always starts too late. By the time teams investigate, the requests are gone. The context is missing, and the problem is already baked into the data. That's why this keeps happening. If proxies sit outside your observability boundary, failures are invisible by design. So how do you fix this? By changing what you observe. In SRE, observability isn't about aggregates, it's about events. You don't debug averages, you debug what actually happened. For crawling, that means one simple shift. One request equals one event, and one unit of analysis. An observable proxy treats every request as a first-class signal. It captures request-level telemetry, where the request went, what domain it hit, what response it returned, whether it was retried, delayed, or partially fulfilled. It preserves context, not just status codes. And it allows tracing, so you can follow a request from the moment it leaves the crawler to the moment data enters your pipeline. This changes debugging completely. Instead of guessing why data quality dropped, you can see exactly which requests failed, how they failed, and where the value was lost. Without this, debugging is retrospective and speculative. With observable proxies, it becomes precise and actionable. That's the core idea. You can't debug what you can't observe. Here's the shift that matters. Crawling pipelines don't usually fail, they degrade. Monitoring tells you that systems are running, but it doesn't explain why data quality erodes. That's why observability has to start upstream at the request level. When you treat proxies as simple network utilities, failures stay invisible. But when proxies become part of your data infrastructure, you gain control. Observability plus validity is what allows teams to scale without losing trust in their data. That's exactly how we approach this at Proxy-Seller. We build proxy infrastructure for companies working with large-scale data collection, analytics, and AI, with observability, responsibility, and production readiness in mind. Our enterprise plans are designed for teams that need transparency, stability, and control at scale. If this was useful, subscribe to the Proxy-Seller channel, leave a like, and follow for more insights on building reliable data infrastructure. And I'll see you in the next video.